What is a cluster? A cluster is the connection between two or more computer systems to improve their processing capabilities or distribute heavy workloads. There are multiple types of clusters, including high availability clusters, load balancing clusters, and high performance clusters, among others. A cluster is a composed of several computer systems or processing units called nodes, and connections between these nodes, the middleware. Among the different types of cluster, this will be focused on the Beowulf cluster. A Beowulf cluster is a type of cluster based on Linux operating system, which has an architecture consisting of several computers in a hierarchical order, meaning there are certain number of slave nodes and master nodes that orchestrates the division of the tasks. This type of cluster use communication libraries such as the OpenMPI library. Throughout these projects, the use of four-node Beowulf cluster was explained, which had the task of processing large images, in order to apply two filters, the solve filter and the convolution filter. The load distributions were analyzed as well the execution times according to the availability of each node.
Developed system. Setting up a Beowulf cluster involves using standard off-the-shelf computers without any specialized hardware or software. We standardized all nodes with the same Linux distribution, Ubuntu 24.04, OpenMPI for message passing, and OpenCV version 2 for image processing. Our cluster consists of 4 nodes, as you can see in the image, one master node that handles coordination, and 3 slave nodes that execute the image processing tasks. These nodes are connected via Ethernet to a switch, forming a local area network. Our image processing algorithm uses MPI to parallelize tasks across these nodes. Here's how it works. First, MPI is initialized and the master node loads the image. Then the master node calculates the number of image rows each node needs to process and sends the data to each node. Each node then applies either a convolution or a solve filter to each part of the image, and the master node collects the processed parts, reassembles the image, and saves the final result. Then MPI is finalized.
Well, continuing with the presentation, we have the two algorithms that we implemented here. The first one is the Sobel filter. This filter is used to detect the edges within an image. First, we take two 3x3 matrices or kernels to detect the edges of the horizon and vertical part of the image, and then we slice each kernel of the image. At each point, we multiply the kernel's value with the corresponding pixel value and sum them up. After that, we combine the result of the horizon and vertical kernels to calculate the edge strength or the gradient magnitude with the next equation that is over here. And after that, we use the gradient magnitude to highlight the edges of the image when we reconstruct the image. After that, we use the convolutional filter that is basically used to apply various effects into an image, such as blurring or sharpness. We're trying to recreate the blurring effect, and then we use a small matrix or kernel for the desired effect. And after that, we use the convolutional process that is basically using a library that makes these 4 steps for them getting the new pixel value, produce the overall effect of the image, and then we recreate the image with these new pixels, and that's pretty much it. Thank you.
Our results involved a table for each configuration used. Then, we calculated average execution times for each configuration and algorithm, which is what we can see in this table. Based on these numbers, convolution algorithm presented the smallest average execution time in every configuration, whereas Sobel algorithm presented the highest average execution time. This also demonstrates that increasing the number of nodes in a cluster does not necessarily translate into a better performance due to overhead and hardware differences inside the test machines. Now, to conclude this research, it can be affirmed as a conclusion that convolution had faster execution times, which suggested a better computational efficiency. Also, we can affirm that increasing nodes did not always improve performance due to communication overhead and workload distribution, and of course, hardware differences inside the test machines. We can also say that Sobel had unstable execution times because of its demanding calculations and the already mentioned hardware differences on the test machines. Finally, a positive aspect about all of this research was that using a router as a network switch proved effectiveness, which enabled location independence and avoided Wi-Fi related issues.